vector is at the origin. So you know what an origin is. Okay, you talked about that in math growing up. If we have a coordinate plane, your origin is right there where the x and the y axis intersect. So when we're talking about vectors, we're putting them on a coordinate plane. And you may have seen on your practice yesterday, there was a coordinate plane with some vectors all over the place. Okay, that's pretty normal. When we're going to look at vectors, you're going to see them on a coordinate plane. Okay, now if we want to find, the component form of a vector, okay, we write it as kind of a comma b, which is just an x and a y value, but we use kind of like the less than greater than symbols to enclose it. We don't use parentheses. That shows that it is the component form of a vector. So if you see here, here's our vector. Okay, it is at the position, the origin. That's the starting point. Does anyone remember what the starting point is from your notes on Monday? The initial point. Does anybody remember what the arrow? We're in terminal. Yeah. So we have the initial point at the origin. Terminal point is at that a comma b. Okay, that's the component form of that vector. So we use that point a comma b. Okay. We talked about finding the magnitude on Monday. Now it's a little bit easier. If you don't have the 2 points, but you just have the component form, you can just do a squared plus b squared and take the square root of that. Okay? So it's kind of like doing x squared plus y squared, because you have x and y values. Okay? This is where we're going to bring in that tangent, okay? The trig that we talked about, what was it, the Tuesday before Thanksgiving? Okay? So you're going to do tangent of b over a. And those two formulas will stay the same. So I'm gonna give you a component form. Tell me what the direction is, okay, which is the tangent, and then tell me what the magnitude is. You're gonna do those. Okay, so it is fairly easy when we work through here. Any questions? Okay, so let's jump right in. If we want to find the magnitude and find the direction angle, we're just gonna we'll just go ahead and do our magnitude first. So we would write magnitude of r. That hasn't changed. You do the double 6. Okay? And from your formula you just got, okay, you do a squared plus b squared. Well, in this case, a is 7 and b is 24. So you do 7 squared plus 24 squared. You will need a calculator today. Go ahead and get that out. Actually, I might just do it up here so y'all can see it. So like I said, I'm a big fan of doing it in parts just because I don't want you to get anything wrong here. So do 7 squared plus 24 squared, which is 625. Okay, now keep in mind, that's under a square root. Okay, that number is under a square root. We haven't processed that square root yet. Then we'll go ahead and take the square root of 625. Okay, it happens to be a nice number, 25. If it's not, I want you to round to 2 decimal places. We're just going to make that a rule, 2 decimal places for everything. Okay, so here, the magnitude of that vector is 25. And we talked about the magnitude of Monday being the size. Okay, it's the size of that vector. So that is the magnitude. And then if we want to find the direction angle, that's where we do the tangent. So if you look at your formula for that, it's b over a. Okay? Does anybody know what this symbol is? Probably theta. Okay? So tangent of theta. That is typically, it's a Greek letter, that's typically how we note an angle. Okay? So we're finding theta is what we're doing. And if you remember, when we did trig, if you put this in, you have to do tangent inverse in your calculator to get that angle measure. So let's go ahead and put that in. So we'll have tangent theta equals, okay, our b value of 24 over our a value of 7. Now when we put it in, in like this. Oops, it'll be that negative first, 24 over 7. Okay. We're going to do that together, so if you have your calculator, go and get that out here. Okay, so you're going to press tangent. I'm sorry, second tangent. That will give you that negative first power. If you press tangent by itself, it's going to be regular. We went tangent inverse because we're finding an angle. And then 24 divided by 7. I think I did change my note. Sorry, I just want to make sure that that's right. Okay. Make sure. Yep, we're not in degree mode. Okay. So right here, if you press mode, right here, go down, make sure it's on degree. If it's not, that's why I got a weird number. Okay. Try it again here. Second tangent. Okay. Now, if you get a weird number, like what I just did, okay, first we need to check our mode, make sure what degree measure. Second, okay, if you get a negative angle measure, we're going to talk about that in a second, but if you get a weird one or a negative one, there's something that you have to do, okay? So weird, we just need to change the degree. So it should be 73 point, we're going to round up 74. So theta, which is, that's the direction angle, okay, is 73.74. Questions for me? Okay, once you get it down, it's a fairly easy process. All right, so we have our next one. First, we're going to find the magnitude. A squared plus b squared, all under that square root, so negative 3 squared plus negative 1 squared. Negative 3 squared is 9. 1 squared, negative 1 squared is 1. So we get the square root of 10. We're going to put that in our calculator. Which is, we'll say 3.16. So it's a little bit of a smaller vector. Okay, next is the direction angle, so we're going to do tangent. Equals, and then is it negative 3 over 1 or negative 1 over negative 3? Negative 1 over negative 3. So make sure on that one, that's something that will happen a lot, is you do A over B by accident, and it's always B over A, so that second number over the first number. Okay, so tangent inverse in your calculator. So get 18.43, say 18.43 degrees. We're going to go with this right. Okay, number 3. Go ahead and find that 9. I'm going to let you do the magnitude. Okay? Something's going to happen when you go to find the direction angle. So go ahead and work on the magnitude by yourself. We'll do the direction angle together. We'll look at here. Should get the square root of 2 of 8, which is 14.42. We okay on that? Okay. Now, the direction angle for this. Okay, you have to check something called the quadrants. You guys remember the quadrants 1, 2, 3, 4 on a coordinate plane? Okay, we're going to label those just in case you do not remember. Actually, no, I'll just do it on here. Okay, where's quadrant 1? Top right. Okay, do you guys remember how to find the rest of them, where, like what the direction is? You use a letter to help you. Does anybody remember? You use a C to help you. So you start in quadrant 1. This is 2, 3, 4. That's how you do the quadrant. You can remember with the C because you start in it. Okay. Now, if we are in quadrant 1, do tangent of your angle. Everything's normal. If we're in quadrant 2, you have to add 180 degrees to your answer. Okay. Quadrant 3, same thing. Quadrant 4, you have to add 360. It's because we deal with negative angles. Okay, so we don't want to write an angle as negative, we want to write it as positive. So that's all we have to do. Okay, so in tangent, here we do negative 12 over 8. Okay, that's B over A. And so when we put it in, tangent inverse, actually, you know what, I'll just do it up here so y'all can see it. Tangent inverse, maybe. Negative 12. 8. Okay, so we get a negative angle, negative 56 point, we'll say 31. Now, we have to check and see which quadrant are we in, okay? And that comes from your component form. So it's a positive x value and a negative y value. So if you look, okay, if we're in quadrant 1, what's our x value? Is it positive or negative? Positive. Okay, same thing with y, right? Positive, positive. If we go over here, which value is negative? The x value is negative, right? If we would plot like negative 2 on the x-axis, you would go over to negative 2. So it's negative, positive on that one, y value. In quadrant 3, what's our x value? Negative. What's our y value? Negative. Okay. Quadrant 4, bless you, would be a positive x value, a negative y value. Okay, so then you look at your component form. We have positive, negative, positive 8, negative 12. So positive, negative is which quadrant? 4. So then we need to add 360 degrees. Okay, so we have to go plus 360. Okay, so our angle is 303.69. degrees. Okay, so that's kind of how that works. If you want to write this down somewhere in your paper, go for it. Okay, that would be a great thing to put in that left-hand margin. Okay, I'll put my quadrant numbers up here too. Okay, number 4, same thing. Go ahead and find your component form. Nope, not tangent. All right, we agree on 12.53? Me. All right, then we're going to do our tangent, theta, 6 over negative 11, our inverse tangent. Okay, there we go. I get a negative number. So that's kind of like telling me, okay, something happened here. Okay. If we look at what we have a negative, positive. So if we go over here, negative, positive is quadrant 2. So we have to add 180 degrees. So what I got was negative 28.61. So I need to add 180 to that, which is 151.39. You have questions for me? Okay. Oh, we have number 5. I thought we only had 4. Oh, 5. Okay. Number 5, go and find your magnitude, which I'm sure you're good at that by now. Square root of 68. Say 8.25. Okay, so there's our magnitude. Okay, which quadrant are we in here? Negative, negative. Quadrant 3. Okay, so we need to add 180 degrees to whatever we get. So we do inverse tangent 2. So I'm getting 75.96. Now, that's a little bit fooling because it's positive. Okay? But because we're in quadrant 3, we need to add 180 to that. So 255.96 degrees. Okay, I want you to try number 6 on your own. Give number 6 a shot on your own. Okay, you have to decide which quadrant you're in on that one. There's my hint. Okay, will you agree with me on the magnitude? Square root of 221, 14.87. Are you okay on that? Okay. Now for our angle, which quadrant are we in here? Which quadrant are we in? Yeah, quadrant 1, it's a positive, positive. Okay, so if we're in quadrant 1, it's normal. We don't need to do anything, which is good news. It's always nice. Okay, so inverse tangent we should get 19.65 degrees. Questions for me? Okay, so that's that. Okay, lots of examples. Now we're going to transition to something where if we had two points, and I want to know, and I ask you what's the component form. Well, we learned how to find the magnitude of 2 points on Monday, but now I'm going to teach you how to do the component form, which in turn makes it a little bit easier to do the magnitude and to do the angle. Okay, so to find the component form, here is your equation. Okay, you're going to have to fill that in at the very top there, I believe. I think it's at the top. Yeah, new page. Okay. It says any vector with initial point x1, y1 and terminal point x2, y2. This is your way of writing component form. So you just do the x's subtracted, comma, the y's subtracted. Fairly easy. Okay. So here, I don't even know if you need to label these. If you want to label an x1, y1, you totally can. I don't think you really need to. Okay. So the first thing we do is we take the x's. 6 minus 3. Okay. Then we do the y's. 3 minus 5. Okay. Now, let me ask you. If you did x1 minus x2 instead, say you did 3 minus 6, is 3 minus 6 the same thing as 6 minus 3? No. Okay, so you have to make sure you do the second x value first. Okay, same thing with the y's. So here for our component form, 6 minus 3 is 3, 3 minus 5 is negative 2. There's your component form. Okay, now from here, if you have this, you could go and you could do what we were just doing. Okay, because here you were just given a component form and then you found the magnitude and angle. Okay, now you have to find the component form, then eventually we'll get to the point where you find the component form, do the direction, and do the magnitude. All right, so here we have negative 2 minus 5 and 1 minus 10. So your x's, x2 minus x1, y2 minus y1, and negative 7 comma negative 9. Okay, questions on finding the component form? Alrighty, let's keep moving. Alright, so number 9. So we're going to do all three things. First, we're going to find component. Then we're going to find the magnitude. Then we're going to find the direction angle. Okay, so for our component form, that's where we do our x's subtracted, so 4 minus 2, comma, our y's, 1 minus negative 9. Now, what happens when we have 1 minus a negative 9? Yeah, plus. You have to add that. Okay, double negative makes positive. So our component form is going to be 2 comma 10. Okay, now what I would get in the habit of doing is looking at that and saying, which quadrant am I in? It's going to help you down the road. Okay, so look at it. Which quadrant are we in when we look at our component form? Plus plus. Right here, quadrant 1. Okay, so that's Q1. That's going to help us down the road. Now we're going to find our magnitude. Okay, how do we find our magnitude? What plus what? X plus y, or a squared plus b squared. Okay, however you want to think about it. So here we look at our 2. We're going to do 2 squared plus 10 squared. So whatever that component form is, that's your A and your B. Okay, now I'm not going to make you write all the different steps. From here you can just plug it in and tell me what the decimal is. Okay, we round that to 10.2. And then last, we're going to find that direction angle, and we're in quadrant 1, so whatever we get, what we get, we're good to go. Okay, b over a. B is 10, a is 2. We'll say 69 degrees. All right, number 10. First thing we do is find that component form. So we have -4 minus 9 for our x's, and our y's, -1. And that would be +3 because you're going to have a double negative, subtracting a -3. So it'd be -13, comma 2. Which quadrant are we in? Yep, quadrant 2, because it's a -13 and a +2, so that's negative positive. Okay, head over to the magnitude. So our A, what was it? -13. For that one, you should get 13.15. Okay, now if you're not getting these, let me know. Okay, troubleshoot with you, make sure everything's good. All right, for our direction angle, B over A, so 2 over -13. Now, whatever we get, what are we going to add to it? We're adding 180 because we're in quadrant 2. So if I do inverse tangent, okay, I technically get -8.75 in my calculator, but since we're in quadrant 2, we need to add 180. Which is 171.25 degrees. Okay, try number 11 on your own. We'll do 12 together, but try number 11 by yourself. Okay, there's the answer for number 11. Okay, that one wasn't quadrant 4 because it was a positive negative. Okay, so you have to add 360. In my calculator, when I did my inverse tangent of negative 7 over 6, I got negative 49.4. Got to add that 360 to it. Okay, any issues or questions working through that on your own? Okay, now number 12, same thing, we're just given a picture, okay, instead of the actual numbers. So what's important? Okay, it's important that you write these points in the proper order. Okay, because the initial point has to come first and then the terminal point. So which one is our initial point? I'll just label them 1 and 2. Okay, which one's our initial point? 1. Okay, very easy on top. Okay, initial point number 1. How do we know that that's the initial point and not the terminal point though? What's special about that terminal point? What does it have? An arrow. Okay, it has an arrow. The initial point does not have an arrow. So our initial point here is negative 1, 4, and our terminal point is 4, 1. Okay, now you can give them like an A and a B if you want to, but it's not necessary. Okay, so we're going to go ahead and find our component form, which would be 4 minus a negative 1, which would end up turning positive, and then 1 minus 4, so we get 5, negative 3. Okay, now you can probably kind of tell okay, we'll just move on. Anyway, what quadrant are we in? Yeah. So this is where, okay, we haven't dug into why. Like, why are these quadrants? Why do we add these 180s? Why do we add these 360s? Okay, we'll get there. I will explain that to you. For right now, just trust me. But it has to do with creating an angle. Okay, so we create an angle from the vector that just so happens to be a quadrant. Okay, and just trust me on that. Okay, but don't look at the picture for quadrant. Go by what you have here. Okay, positive, negative. All right, so for our magnitude, so that would be 25 plus 9, 36, no, 34. So square root of 34. Yeah, oh no, sorry, 5.83. Okay, now that we're in quadrant 4, what are we going to have to add to our angle? What do we have to add to our angle? Y'all are so talkative today. What are we going to add? 360. We're in quadrant 4, so we're going to add 360. Okay, now you don't have to show me this, like the negative. You don't need to show me that. Okay, I'm doing that for note purposes so that you know that you're getting the right answers when you put it in your calculator. Okay, but you don't need to do that. You can go straight from here to this. Okay, that's all you have to do. You don't have to show me all that between stuff. Okay. Now, the last step here is to show, is to do this, but do it with 2 different vectors and see if they're equivalent or not. Okay, we did that on Monday, but we just did it with the slope formula and the distance formula. Okay, now it's going to be a little bit easier. Okay, so it says vectors are equivalent if and only if they have the same component form. We don't even have to find we don't have to find direction. We don't have to find magnitude. We just have to see do they have the same component form. Okay, so if we look at AB, okay, if we find the component form of just AB, we would do -7. That'll end up being +3, because it's minus a negative. And then -2 minus 6. So what do we get here? -4, -8. Okay, now we're going to find the component form of CD. If the component form of CD is the same, then yes, they are equivalent. So we would have -1 minus 3, -9. That would end up being +1. Okay, watch your negatives on there, double negative. -4, -8. So yes, right here. Okay, because this, maybe, okay, because this is the same as this, that shows that they are equivalent. Okay, last one. Same thing, go ahead and do your component form of AB. And then CD. Okay, are they equivalent? Close, right? But here, we have two positive 9s, that's good, but we have a -6 and a +6. Those are not equivalent. Okay. The practice, I know you did the first part of it, the first page of it. The second page of the practice is for this, okay, for these notes. So if you want to go ahead and practice that, I highly suggest it. Tomorrow we're going to have a small quiz at the end of the period. Okay, it looks like a half sheet, very, very small. We'll do mixed practice from Monday and today before that. Okay, so you should be okay for that quiz by the time we get to the end of the class period tomorrow.